Hello, my name is Roberto and I'm a software engineer at WhatsApp. I spend most of my time working around the Erlang IDE and developer tools for the Erlang programming language. Together with my team, in the past few years, we have been releasing a number of tools that can dramatically boost your productivity when it comes to working with Erlang code. From the ErlFMT formatter for Erlang to the equalizer type checker, from the ELP language server to the new EDB debugger. And all of these tools are available as open source projects. So I figured that it would make a lot of sense to showcase what they can do for you, what you can expect from them, so that you can see how useful they can be they could be in your day-to-day job. In this episode, I want to show you one feature. I want to show you how to trigger and debug tests, Erlang tests from the IDE. We will be using Visual Studio Code for this demo, using some feature that it's called code lenses. So let's get to it. So here I have my Visual Studio Code. I pre-installed the Erlang language platform extension. So if I go to the extension menu and I search for Erlang, you can see this Erlang language platform extension here. It's already installed. If you don't have it, you can install it through the extensions menu, or you can also visit the Visual Studio Marketplace. You can search for Erlang. And this is the one, the Erlang language platform is the one that I'm using. But let's go back to VS Code. In my workspace, I already added a project. For the demo, I'm using ErlFMT, is the Erlang formatter that is developed at WhatsApp. It's also an open source project. It's available on github.com, WhatsApp, ErlFMT, and it's a way to auto-format your Erlang code. If you haven't been using ErlFMT, you are missing out and you should give it a try. But that's out of scope for this episode, where the only thing that I care about ErlFMT is that ErlFMT is a standard Rebar 3 project. Rebar 3 is a build tool, which is pretty common in the Erlang community. And you can recognize it's a Rebar project because it has a Rebar configuration in its own root directory. So we are going to open a test suite from ErlFMT. So inside ErlFMT test, I have this ErlFMT algebra suite, and you can already see that I'm using the ELP extension because I get some features. The file is recognized as Erlang, as you can see at the bottom of the screen. You also get syntax highlighting, you get bulbs, you get these little buttons, which are known as code lenses and so on. Today we are going to focus exactly on these buttons, so let's see what they are. We see a bunch of them. We see they are at the top of the file above the module definition. We have a few. We have the open REPL, we have the run all tests, and the open debug REPL. We'll see what they do. And if we scroll down, above each test case, we also see the running REPL, run test, and debug. You have settings where you can decide which one you want to see or you want to hide, depending on your own preferences. So starting from the beginning, the first trivial thing that we can do is that we can run all tests which are contained in this test suite. So we click on the button, and the only thing that it does really is to execute in a terminal the Rebar3 CT suite command. And you could do this by just switching to a terminal and searching in your shell history or typing by hand, but I mean, this is just faster. And you can also associate shortcuts to code lenses so that you can make this workflow much faster, especially if you're running tests multiple times. So that was easy. We can also run individual test cases by clicking on the run test code lens, which will run a specific test case. But we have a few other options. One which is very convenient is the open REPL code lens, which will open a Rebar3 as test shell. So open a shell in test mode. And then you can use the open shell where you can do whatever you want. Is an Erlang shell. You can run a specific test in the REPL. So once you have a REPL open, you can click on run in REPL, and this will run a slightly different variation of the Rebar3 command to execute the test. This is convenient if you want to do some initialization, for example, in your shell, and you want to run tests after that without repeating the initialization step. But the most powerful thing that I want to show you is the debug REPL and how you could actually debug your Erlang test cases using the new EDB debugger. Before we can do this, we have to do a little tweak to our rebar project though. So we open the rebar config, and what we are going to do is to add a Erlang compiler option to the test profile for our project. What is this? So these Erlang options are passed to the Erlang compiler when we build our project, for example, for a release, or as in our case, for testing purposes. So in OTP 28, the new version of the compiler actually introduced a new option, which is called Beam Debug Info, and it's an experimental API for native debugger, blah, blah, blah. So essentially, by adding this, you compile the file with some special information the EDB debugger will need. The EDB debugger is yet another project that is being developed at WhatsApp, github.com, WhatsApp EDB, and allows you to debug Erlang code. So to enable the debugger, the compile file needs to have this Beam Debug Info option, where the Beam files will have additional information which is used by the debugger. There is some kind of a performance penalty when you introduce this flag, but we are testing, so we don't really care about that. It's totally fine to have it. So we will go to our VS Code, we go to the testing profile, and then we add a new option. So we say Erl opts, and then we add the Beam Debug Info. And that's pretty much it. Our project is ready to debug, to use the EDB debugger. So now let's go back to our test suite, ErlFMT algebra suite. And let's start by, for example, going to a test case and clicking on the debug button. But before doing that, we can add a breakpoint. We click on the debug button. And as you can see, the debugger started with very minimal effort, and we have a shell available, and we can use the debugger. We can step in, we can see process information, messages in queue, and so on. I will do a different, a separate episode about the debugger features. That this is just for triggering the debugger, but it's the UI is essentially the same for other debuggers in VS Code. So we can step, and then we can continue execution, and all the tests are passed. A slightly different variant of this flow is to use the open debug REPL at the top. The difference is that if we click on this open debug REPL, we essentially get a shell, but the shell, the tests are not executed as part of the same operation. So we get the shell, and we can do our own initialization or whatever, and then we can go to each test case, and this time I don't want to start a new debug session, but I want to run the test in the REPL, which is now available in debug mode. So the breakpoints will actually work. So if I run the test, you can see here that everything works as expected, and I can step and I can continue. And this flow is very convenient because if I have some very heavy initialization that I want to do, I can essentially perform that initialization once, and I can iterate by running just the single test case in the same shell. That's really all I wanted to show you for this episode. I hope that you find this kind of tips useful, and this can give you a better idea of what tools such as the EDB debugger or the ELP language server and extension can give to your day-to-day job. So see you at the next episode.